Hi there, I'm David Floyd and I'll be discussing results from my research into technical leverages in split-screen FPS games today. I originally took interest in this line of research as no modern efforts have been made in the area, and in the age of giant TVs and superior resolutions, it felt like a worthwhile endeavour. Lately, local multiplayer games are becoming increasingly scarce. This is commonly believed to be caused by the internet and the desire for graphic fidelity by the community. These desires are responded to by developers with increasing graphics and removing process-heavy functions that add unnecessary scope. Despite the behaviour and inclinations of developers, local multiplayer and split-screen games are still commonly sought after by gamers, especially around Christmas. So if a developer wants to hop on board the local multiplayer bandwagon, split-screen is an option they can consider. However, in modern game development environments, it dramatically increases resource requirements for each player participating. So I wanted to answer the question, what leverages can be used by developers to facilitate local multiplayer functionality? While that is quite a broad question, targeting a particular feature of games, it offers an opportunity to analyse development strategies. To achieve an answer, statistics need to be acquired from testers after being exposed to the leverages in a game-believable simulation. These statistics could then be used to identify user preferences. Lastly, analysing the data to create suggested approaches for developers to consider as a result of the research. To accurately research these leverages, the simulation was made with multiplayer capacity, and to achieve similar results from all users, the map was made in a cross with identical features in each player hub. The hub itself was themed as a terraforming space station on a barren planet. To limit player mobility, the station was also located in a crater. As the simulation needed to be developed to a high enough standard within the limited time constraints, use of several third-party assets was required. Fortunately, the project was built in Unity and utilised first-person shooting, which my major project Gunforge assisted with, though some modifications had to be made to handle the multiplayer aspect of the simulation. The largest time saver was a map pack supplied by Carboosts, and allowed for rapid development of the map with 2 levels of VLOD. Originally, I created a high-poly environment of a factory as per the original pitch, but hurting for time and not being certain of my testing window meant I had to unfortunately swap it out for a modular build. After the level was developed, a basic gun and player model was added, along with the implementation of audio that was supplied by Bensound and SoundBible websites. The code requirements for the simulation were fairly straightforward. The round and leverage managers worked together to structure the simulation by delivering 9 testing scenarios, the first being the optimal scenario, 60 frames per second, 1080 resolution per viewport, and 100% of assets. Frame rate was then dropped via disabling of VSync and manually setting the application's target frame rate. Resolution was reduced via rendering the camera's view to a render texture and dynamically scaling the texture depending on the scenario. Most other requirements were atypical of a first-person shooter, barring the ghost shader, which was used to signify a player death and give dead players something to do until the next scenario started. Testing was performed at the Academy of Interactive Entertainment in Melbourne, with the help of first and second year students. The testing was achieved with a standard PC display, a projector, and 4 Xbox controllers. During testing, no real complications occurred, barring some confusion from testers about controls, and the ability for them to travel through walls as a ghost, yet still retain the ability to interfere with other players. Additionally, I'd like to thank AIE teacher Adam Clark for assisting with obtaining and organising testers. After running the simulation, testers filled out a web-hosted survey that asked 10 questions. The first 2 identified their gaming preference and whether they played first-person shooter games, which, of the 33 testers, nearly all identified as PC gamers that like the genre. At first, this result was unexpected and gave me concern, as PC gamers are not the ideal demographic to test local multiplayer on. As PC gamers tend not to be targeted by developers for games to have split-screen functionality, common sense would dictate that most computers have one user, hence no reason to develop local multiplayer features for it. Regardless of this, most testers still claim to play local multiplayer games. And even with this deviation, a majority of testers still claim they would pay more for a game with local multiplayer options. Testers showed strong preference for gameplay over graphics. This result, while unsurprising, suggests that developers could possibly let up on graphic fidelity in this current generation of games. The impact that extreme visuals has on development resources is tangible for any developer, and from looking at this graph, they may not even be in the best interest of a prospective gamer. That assumption is, however, outside the field of this research and likely has correlations with marketing and advertisement. Testers also favoured frame rate over resolution, though not as strongly as gameplay. Few testers also commented that while they aren't strongly opinionated about high frame rates, they prefer a stable 30 FPS over a choppy 60 FPS. The last scenario tested pushed the boundaries of functional gameplay within the simulation. Most testers in this scenario could barely identify other players, and many commented that the visual feel of the scenario was reminiscent of early FPS games. While most testers were impacted severely, some outliers claimed that it felt like they were playing in slow motion and it actually made it easier. As the simulation was purely built in fixed update, I'm not sure what to make about these statements. Other notable results of the study found that most testers could identify between 60 and 30 FPS. The average suggests that frame rates of 45 FPS would be an ideal goal for developers. However, that is not a supported standard in current technology. When asking users how important their screen size was to them, a rating of 6.3 was averaged. This suggests that some play with resolution could be utilized, though resolution is the least likely leverage to employ, especially in console games. Controversially, the leverage that could be applied to improve performance is the actual removal of assets from the game. As long as they were purely cosmetic and offered no mechanical advantage to players, things that went right. In general, it was having the development of the simulation completed on time and having more testers than expected participate. As things were rocky on day one, and attendance rates at the academy were unfortunately low. Also, seeing people actually enjoy the simulation and mess with their classmates as ghosts was a personal highlight. Often I'd find that players would like to interfere with each other, and some would even gang up on each other to stop people from moving. Things that went wrong. The biggest concern I had when testing was a visual bug I didn't spot before deploying the tests on day one. Player 4 had no visual feedback for where their bullets were travelling, and this led to issues with a couple of testers. The biggest issue I had overall was during development. Lack of experience with Xbox controllers would inevitably cause me some damage. The amount of time lost to trying to figure out why the trigger on Player 3's controller fired bullets from Player 1's gun was embarrassing. This was eventually circumvented by forcing testers to use bumpers instead of triggers, which was less than ideal. Lower on the list was the number of assets utilized when testing the asset reduction scenarios. This may have had tangible effects on the results. And last was the unexpected amount of programmers that participated in testing. Whilst not exactly something that went wrong, programmers do tend to be PC enthusiasts. In closing, results led to the conclusion that frame rate is vital to a gamer's enjoyment. Little leverage can be applied here, however priority on 60 FPS may be lost on most users. Resolution can be somewhat compromised, though this depends on hardware. Having the option to drop output to 720p to improve performance above 30 FPS would be a viable strategy. Lastly, asset reduction is the largest leverage that can be applied. Research into exactly what cosmetics affect a gamer needs to be conducted. Possibly extending the research Mary Keogh performed in 2017 that analysed graphical styles and evaluating the technical benefits that could be attained from a particular artistic limitation. On top of that, additional research into actual performance advantages from these kind of limitations could be advantageous. And that's my presentation. Thank you for watching.